Hello everyone, welcome to the video. Today we're going to be starting a new tutorial on how to make different light patterns with the Arduino. So this is going to be a series of like multiple tutorials, and I'm going to be showing you all different types of light patterns you can do with the Arduino. And so I'm going to go ahead and I'm going to show you how to set up the circuit. Then I'm going to show you how to make a false light pattern, which is going to be a Knight Rider. And so basically here is the circuit right here. We have 6 LEDs. The first LED is going to be connected to pin 11. Then the second is going to be connected to pin 10. Then the third is going to be connected to pin 9. The fourth is going to be connected to pin 6. The fifth is going to be connected to pin 5. LED 6 is going to be connected to pin 3. And all these LEDs are going to be using 330 ohm resistor. So these are 330 ohm resistors right here. And you can use any type of resistor in between 200 ohms up to 470 ohms. Any resistor in between there you can use with the LED. You can only use pins on the Arduino that you can use PWM with, because in the future I will be making other light patterns where some LEDs are not going to be full brightness and some LEDs will. And so to do that you have to use PWM. So we're making a circuit that's also not just for the Knight Rider but other light patterns that we're going to be making in the future as well in the coming tutorials. Then we have a potentiometer. Now in this tutorial I'm not going to be using the potentiometer, but I will just be adding in the circuit because we will be using it in the future. And so one side of the potentiometer is connected to ground, the ground rail, and the other side is connected to positive 5 volts, and then the middle pin is connected to pin A1. You could choose whatever analog pin you want with connecting this pin. And so then all the LEDs, they're all connected to ground, as you can see, and the ground rail is connected to a G&D on the Arduino. And so basically go ahead and set up the circuit, and then we are going to continue and look at the code. Okay, so now here is the code. So the first thing we do in this code is we go ahead and do constant pot pin equals A1. So basically this is for the potentiometer. Although we're not going to be using this in this tutorial, we just put the pin number value in the parameter so that we can use it later. And so then we have LED pins. This is a array, and this array will be holding all the pins that we are using with our LEDs. So pin 11, pin 10, pin 9, pin 6, pin 5, and pin 3 are all in this array. And then we have an array of LED state. So each one of these numbers, you can see that there are 6 slots right here, and each one of these values represents one LED. So in this case 255 is the maximum PWM number that you can give to a digital pin, and that will mean full brightness. 0 means no brightness. So right here we are telling if which LED is on and which LED is off. So as you can see, 255 means it's fully on, and the full slot means the LED that is connected to pin 11, which is LED 1. Okay, so at first LED 1 is going to be on because this is 255. This is for LED 2, which is connected to pin 10, LED 3, which is connected to pin 9, LED 4, which is connected to pin 6, LED 5, which is connected to pin 5, and then LED 6, which is connected to pin 3. So as you can see, it's all in the same order as it is up here, so that not only do we have the pins that these LEDs are connected to, but we know if they are, which LEDs are on and which LEDs are not. And then we have LED direction, and so this is going to be telling us which way the LED of the Knight Rider will be going, if it's going this way or that way, because our LED is going to be going back and forth. And so are we going this way or are we going that way? This variable will be telling us that. So positive 1 means that we are going one way, and then negative 1 means we're going the other way. And then we have modes. This is for later on in the future, because we're going to be adding more LED patterns to this project. And so as we add more LED patterns, then we will add more modes so we can switch through the different LED patterns. Then we go into the void setup, and we do 0.begin 9600 baud rate. We'll just set up the serial monitor, and then we go ahead and set up all of our pin numbers that are connected to our LEDs. And so what we do is we just go ahead and we use a for loop to iterate through this array right here and just setting up all of the pins. Okay, so the first thing we do is we go ahead except J, which we're going to make it equal to 0. So J equals 0. And then we're going to say continue looping this for loop until J is no longer less than 6. So basically when J is equal to 6, then we'll no longer come into this for loop. And every single time we loop this for loop, we are going to increment J. So we're going to go through this for loop 6 times. And there are 6 pins in this array right here. And so what we're doing is we're doing pin mode, LED pin, J. So J is going to be incremented every single time we come through this for loop. So at first, J is going to be equal to 0. And 0 is going to be put into this LED pins. And what pin is in the 0 slot? 11. So we're going to go ahead and define 11 first. And we're going to say it's an output. And then we'll go through again and loop it. And now we are incrementing J. And so now J is equal to 1. And since J is right here, this is where we put the number to get what slot we want to get out of this array. And so we're just putting J there, which now is equal to 1. So what pin number in this array is in the 1 slot? That is 10. So we'll go ahead and define 10, and that's going to be an output. And we're going to continue looping. We'll define 9, 6, 5, and 3. We'll define them all. And then we go ahead, and after we're done iterating through all these 6 pin numbers, then we come out of this for loop and then get out of the void setup. Okay, so now we'll go into the void loop. And then again, this is kind of the same concept. We use the for loop again, and we do the exact same thing. Basically, make J equal to 0. So now J is set back to 0. And we're going to say, as long as J is less than 6, then continue looping this for loop and increment J every single time we come through this for loop. And what we do is we do analog write. So now you may be wondering, okay, I thought you couldn't analog write to a digital pin. Well, you can, but it can only be a pin with PWM. And so that's why we only chose specific pins on the Arduino that have PWM. So that we can analog write to them, because in the future these LEDs will not only be just fully on but be dimming, things like that. So we want to have this option to be able to dim LEDs, so that's why we did this. Okay, so now what we do is we do LED pins. So at first, when you are analog write to an LED, you have to define the pin. So again, we do the same thing as we did up here. We'll go ahead and do pins, which is holding all the pin numbers in that we are using with our LEDs, and we'll put J inside, which will be giving us the number of the slot of which LED we should be turning on or analog writing to. And so then the second one here is LED states, and we kind of do the same thing. We do LED state J. So basically in here, the first one, which is pin 11, which is LED 1, will be fully on. So we're going to iterate through these, and J is going to continue increasing to 1, 2, and 3, and they will be all 0, as you can see. So all these LEDs to 10, 9, 6, 5, 3 will be all set to 0, which is off. So yeah, that's what this is. And so all this for loop does is kind of updates and turns on and off all the LEDs that need to be turned on and off. So that's what this for loop does. Okay, so now I'll go to the switch statement. If you don't understand the switch statement, I have a link down below to a tutorial that I made. I recommend you go look at that to understand more about the switch statement. So what we do here is we use modes. So modes is going to be holding what current state or what mode we're at, like which pattern we want to do. And right now we only have one pattern, so modes isn't really useful right now, because we're just making our first pattern, which is the Knight Rider. But as you can see, we have multiple cases, go all the way up to case 5. So we'll have 5 different patterns in this project eventually, as we go on to our tutorials. But right now we are making our first one. And so this is all the functionality for the Knight Rider, which is in case 1. So case 1 is basically if modes equals 1, then come into this case statement. And so then in this case statement, we have a for loop. Then we do int J equals 0. So we're just resetting J and J again, making it 0 again. And we say we're going to continue looping this for loop until J is no longer less than 6. And then every single time we loop this for loop, we're going to go ahead and increment J. So eventually J will become equal to 6 or no longer less than 6, and we'll come out of this for loop. Making it so that we actually loop this for loop 6 times, which is as many LEDs we have. So what we'll go ahead and do is say if LED state, which is the array that's holding all the states of all LEDs, if they're on or off, and then we're going to say equals 255. So basically we're going to go through this array one by one every single time we loop this for loop and check if the LED is on. So first we'll go through LED 1, we'll check if it's on. LED 2, we'll check if that one's on. And we'll continue going through until we find one that is on, which is 255. That's the full value that we give to a PWM pin to turn it fully on. And after that, they would come into this if statement, because what we're going to do is when we find a LED that's on, we got to turn on one of the LEDs next to this LED that's on. Okay, so we have to come into this if statement and determine which LED we turn on, the one on the right side or the one on the left side. And so how we determine that is we come to here and we say if j equals 5. So basically, if j equals 5, that means the LED that's currently lit is LED 6. So that's the last LED of the LED strip that we have. And so then we say and LED direction is equal to +1, which means it's going to continue going up the value. Then we want to go ahead and come to this system, because basically if we are at LED 6 and we are continue to go higher, then we need to turn the direction around, because we are at the last LED of our strip. We need to go back now. So that's what we do. We come into this statement, and there is no reason why we have this serial monitor here. I was just doing some tests, but anyway, so what we do is make LED direction equal to negative. So we are just going to be flipping their direction, so that now the lit LED will be going back. And so now if LED 1 is on and LED direction is negative, that means we are going back, and 1 is the last LED, so we want to go ahead and turn the direction and go back up again. So we want to come into this if statement if this is the case. But if, let's say for example, we are on LED 1 and LED direction is 1, that means we are going forward. And so we don't want to come into this if statement because we don't have to turn LED direction around. But in this case, if this is true, then come in here and make LED direction to +1, changing the direction. So then after that the direction is set properly and that we're not going to go out of the strip, then we want to go ahead and do this. We do LED state j equal to 0. So the current LED that is currently on right now, we want to go ahead and turn it to 0. Basically, turn it off. Same in the array that we are turning off this LED. Okay, but we're not actually turning this off this LED right here. But once this gets out of the switch statement, it will come up here to this code again, and this for loop will turn this LED off. So then after that, then we go ahead and do j equals j plus LED direction. So this is how we determine which LED we're going to be doing, like the one next on this side or the one on this side. It depends on LED direction. If it's negative, then we're going back. Okay, so what we're going to do is we do j equals j plus negative. In that case, then we are decreasing j. But if it's j plus 1, then we're going to be adding 1 to j. So if we're going forward, then we're going to be adding 1 to j. But if we're going back, then we're going to be taking 1 away from j. And so this depends on which direction we are going on our LED strip. Okay, so that's how we do that right here. We either subtract or add in this case. Okay, and so now we go ahead and do LED state j, which has been updated to which LED we are going to be brightening up next. We're going to make it equal to 255. That is fully on with to a PWM pin. So basically what's going on here is we turn off the current LED that is on, and then we just determine which direction we're going. And if we're going back, then we turn on the LED on this side. If we're going forward, then we turn on the LED on this side. Then we go ahead and come out of this case statement and go through all these case statements, which right now are empty because we haven't made patterns for them yet, and we haven't added the functionality to these yet, but we will in the future tutorials. And then we come down here and wait a half a second so that this Knight Rider isn't going real quick. And so then after that, we come back up here. This for loop makes the updates on what we had made inside of here. And then we'll just do the code over and over and over again. So basically that is the code. Now I'm showing you the project in action. Okay, so now here is the project, and as you can see, we have our LEDs that have a light going back and forth. So this is basically a Knight Rider pattern where the LED goes back and forth, and eventually we'll be able to control the speed of this Knight Rider with this potentiometer, but right now I didn't add the functionality to it yet. And in future tutorials I will. but right now we're not doing anything with it. But right now we just kind of have the pattern of the Knight Rider LED, as you can see. And so basically this is the project. If you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing and we'll see more content like this. Thank you all and have a great day. Bye.